All right, so in this video, I'm going to be showing how to prove that every open ball is an open set. And so, important thing is to take note of the definition of open set to know where we're going with this. Um, so a set U is open if and only if for every x in U, there's an epsilon greater than 0, such that an open ball with radius epsilon around x is contained in U. So for any arbitrary element in our open set, we can fit an open ball around it and have that open ball still contained in our original set. Okay, so starting this proof off, suppose we have an open ball around x naught with radius r. And we can draw a picture of that, and this helps out big time to kind of get a visualization of what's going on. And yeah, just the picture in 2D helps out. So right here with radius r. Okay. So let's choose an arbitrary point y in our open ball. So let's just choose this y right here. And then so the distance between x naught and y is going to be less than r, right? It's inside our open ball, so that distance is going to be less than r. So then that distance is less than r. So what we're trying to do is to determine the radius that we can fit around y such that we're still staying inside this open ball. So for any random point, any arbitrary point that we're picking in here, it's also going to be an element of this original ball. Okay, so yeah, we need to figure out what this radius is. And what we can do is we can set this radius, and we'll call it S, equal to R minus X naught, or Y minus X naught. What that does is that guarantees us that S is going to be greater than 0. Right? So we'll have a positive radius, and it's also smaller than R. Okay. Now, so if we have a random arbitrary point in this new open ball that we've created, then that distance between x and y is going to be less than s, right? So this is s, and so if we choose any point inside here, distance between x and y is going to be less than s. Okay. Right, and so now what we need to show is that the distance between x and x naught is going to be less than r. Because if this distance is less than r, what does that tell us? It tells us that this point is also, that's an element of this ball, is also guaranteed to be in this ball, which satisfies our definition for the original open ball to be an open set. So we can look at this equality here, right? And we want this to be less than r, right? So that's what we need to show. So what we can do is add y and subtract y. And then using the triangle inequality, we can break this inequality up. And what we get from this one is that r is equal to S plus y naught minus x naught. And right, we have x minus y. Distance between those 2 points, or between x and y, is less than s. So we have less than s plus y minus x naught, which is equal to r. So there we have it. We have that the distance between x and x naught is less than r. So thus, for every arbitrary element in that second open ball that we fixed, x is also guaranteed to be an element of our original open ball, which satisfies the definition for this open ball to be open set. And run out of room. Yeah, that's it. Yeah, now we know that for any random point that we've chosen here, the distance between that and x naught is going to be less than r. So we know for any point in here is also guaranteed to be a point in here, which is going to help us satisfy that definition for the original open ball to be an open set. Yeah.